In electronics, a multiplexer is a device that selects one of several analog or digital input signals and forwards the selected input into a single line. A multiplexer of two n inputs has n select lines, which are used to select which input line to send to the output. Multiplexers are mainly used to increase the amount of data that can be sent over the network within a certain amount of time and bandwidth. A multiplexer is also called the data selector. An electronic multiplexer makes it possible for several signals to share one device or resource. For example, one A/D converter or one communication line, instead of having one device per input signal. Conversely, a D multiplexer is a device taking a single input signal and selecting one of many data output lines, which is connected to the single input. A multiplexer is often used with a complementary D multiplexer on the receiving end. The schematic symbol for a multiplexer is an isosceles trapezoid with the longer parallel side containing the input pins and the short parallel side containing the output pin. The schematic on the right shows a 2-to-1 multiplexer on the left and an equivalent switch on the right. The wire connects the desired input to the output. Cost saving. One use for multiplexers is cost saving by connecting a multiplexer and a demultiplexer together over a single channel. The image to the right demonstrates this. In this case, the cost of implementing separate channels for each data source is higher than the cost and inconvenience of providing the multiplexing, demultiplexing functions. At the receiving end of the data link, a complementary demultiplexer is normally required to break single data stream back down into the original streams. In some cases, the far-end system may have more functionality than a simple demultiplexer, and so, while the demultiplexing still exists logically, it may never actually happen physically. This would be typical where a multiplexer serves a number of IP network users and then feeds directly into a router, which immediately reads the content of the entire link into its routing processor and then does the demultiplexing in memory, from where it will be converted directly into IP sections. Often, a multiplexer and demultiplexer are combined together into a single piece of equipment, which is usually referred to simply as a multiplexer. Both pieces of equipment are needed at both ends of a transmission link because most communications systems transmit in both directions. In analog circuit design, a multiplexer is a special type of analog switch that connects one signal selected from several inputs to a single output. Digital multiplexes. In digital circuit design, the selector wires are of digital value. In the case of a 2-to-1 multiplexer, a logic value of 0 would connect to the output while a logic value of 1 would connect to the output. In larger multiplexes, the number of selector pins is equal to where is the number of inputs. For example, 9 to 16 inputs would require no fewer than 4 selector pins, and 17 to 32 inputs would require no fewer than 5 selector pins. The binary value expressed on these selector pins determines the selected input pin. A 2-to-1 multiplexer has a Boolean equation where another two inputs is the selector input and is the output, which can be expressed as a truth table, or, in simpler notation, these tables show that when then but where then. A straightforward realization of this 2-to-1 multiplexer would need two AND gates, an OR gate, and a NOT gate. Larger multiplexers are also common and, as stated above, require selector pins for inputs. Other common sizes are 4-to-1, 8-to-1, and 16-to-1. Since digital logic uses binary values, powers of 2 are used to maximally control a number of inputs for the given number of selector inputs. 4-to-1 mux, 8-to-1 mux, 16-to-1 mux. The Boolean equation for a 4-to-1 multiplexer is: the following 4-to-1 multiplexer is constructed from 3 state buffers and AND gates. Note that the subscripts on the inputs indicate the decimal value of the binary control inputs at which that input is led through. Chaining multiplexers. Larger multiplexers can be constructed by using smaller multiplexers by chaining them together. For example, an 8-to-1 multiplexer can be made with two 4-to-1 and one 2-to-1 multiplexes. The two 4-to-1 multiplexer outputs are fed into the 2-to-1 with the selector pins on the 4-to-1's put in parallel, giving a total number of selector inputs to 3, which is equivalent to an 8-to-1. List of ICs which provide multiplexing. The 7400 series has several ICs that contain multiplexer. Digital D Multiplexes. D multiplexes take one data input and a number of selection inputs, and they have several outputs. They forward the data input to one of the outputs depending on the values of the selection inputs. D multiplexes are sometimes convenient for designing general-purpose logic, because if the D multiplexer's input is always true, the D multiplexer acts as a decoder. This means that any function of the selection bits can be constructed by logically ORing the correct set of outputs. If X is the input and S is the selector, and A and B are the outputs. List of ICs which provide demultiplexing. The 7400 series has several ICs that contain demultiplexer. Multiplexers as PLDs. Multiplexers can also be used as components of programmable logic devices. By specifying the logic arrangement in the input signals, a custom logic circuit can be created. The selector inputs then act as the logic inputs. This is especially useful in situations when cost is a factor and for modularity.